My part in this project was mainly focused on data preprocessing and logistic regression. First, I worked on preprocessing the data set. Before training any machine learning model, the data has to be cleaned and organized properly. So I check for missing values, remove duplicates where necessary, converted categorical data into numerical format, and prepared the features in a way model could understand. I also split the dataset into training and testing sets. This step was really important because even a good model will not perform well if the data is not prepared correctly. After that, I implemented logistic regression. Logistic regression is a classification algorithm. So in our project, it was used to predict the output class based on the input data. I trained the model using processed training data and then evaluated it using the test data. To measure how well it performed, I looked at matrices like accuracy, precision, recall, and F1 score. Also, the confusion matrices, ROC Curve, ROC Curve. One reason logistic regression was useful is because it is simple, efficient, and easy to interpret while still giving a solid result. So, overall, my contribution was preparing the data properly and applying logistic regression to build a classification model. These steps were important because preprocessing improves the quality of input data, and logistic regression gave us a clear baseline for prediction.
Let's say, and my IT number is IT 2001289. So this is for the ML assignment. So I was tasked with decision tree. So what I did was, so first we loaded up the data and stuff for the imports and stuff, and then we started hyperparameter tuning. So I set up a grid of different settings for the decision tree, with max depth, min sample to split, min samples per leaf, criterion, pruning alpha. Then I pass the grid into grid search CV. Visualize every combination, trains the model with each one using 10-fold cross validation, and place the combo with the highest F1 score. And the best parameters it found were entropy max, max entropy, and then the max depth was 5, and the min sample split 7, and the CCP alpha 0.002 0.02. So and then we did model evaluation. So I took the best model from the research event, used it to predict on the test set, and then I calculate accuracy, precision, recall, F1, AUC-ROC using SQL and symmetric functions. I also printed the tree depths and the number of leaf nodes to see how complex the final tree is, and then we did three k fold cross validation was the third part. So I ran the cross validation score on the tuning model with k set to 5 and 10. This splits the training data, trains and tests k times, and gives an array of F1 scores. I printed each fold score plus the mean standard deviation to see how stable the model is. So this is that. And then the next one was confusion matrix and the ROC curve. I used the confusion matrix to get the 2 by 2 table and predictions, then plotted it using confusion matrix display. For ROC curve, I used ROC curve, which takes the actual labels and predicted probabilities in false positive rate and true positive rate. I plotted those. I also gave the diagonal line to show what random guessing looks like. And then the next part was the tree visualization and the feature importance. So this was the tree visualization. I used plot tree from SQL to draw the full decision tree with feature map names, class label, and fill in. For feature importance, I grab the model feature importance, which gives a score for each feature based on how much it reduced the impurity. in each class based on how much it is input across all splits. I loaded them and plotted a horizontal bar chart and printed the top 10. So there is that. Thank you.
I implement the random forest algorithm for our machine learning project. First, random forest is supervised machine learning algorithm that works by creating multiple decision trees and combining their result to make one final prediction. Instead of depending on one single tree, it uses many trees so the model become more stable, more accurate and less likely to overfit. In my notebook, I firstly load the preprocessed training and testing datasets. The training and training data contain 241 rows and 30 features, while the test data had 61 rows and 30 features. After that, I used grid search CV for hyperparameter tuning. This means I tested different values of such as number of trees, tree depths, minimum sample split, and minimum sample leaf. The purpose of this step was to find best combination of parameters for the random forest model. The best cross-validation F1 score was around 0.8647, which indicates good model performance. Next, I evaluate the model on test data set. The model achieved accuracy of 81%, precision of 82%, recall of 84%, and F1 score of 83%. These results show that the random forest model performs well in identifying hard disease cases. I also use fivefold and tenfold cross-validation to check stability of the model. Both results were very close with mean F1 score around 0.86, which shows that the model is consistent and reliable. Now these are the confusion matrix and ROC curve. The confusion matrix shows how many predictions were correct and incorrect. It helps us clearly understand the number of true positives, true negatives, false positives, and false negatives. The records shows the performance of the model across different qualification thresholds. The beta curve indicates that the model can separate positive and negative classes effectively. Finally, I plotted the feature importance charts. This visual shows which input features had the biggest influence on the prediction. So this chart helps us understand which medical factors was the most important for the random forest model. In summary, random forest gave a strong balanced performance and it was a very useful model for this heart disease prediction project. Thank you.
In this part, I implemented the K nearest neighbors algorithm for heart disease prediction. The goal of this model is to classify whether a patient has heart disease or not using the given dataset. First, I loaded the preprocessed training and testing dataset where the target variable is target and the remaining columns are used as a feature. Then I applied the KNN algorithm and performed hyperparameter tuning using grid search CV to find the best value of K. I tested values from 1 to 30 and selected optimal value based on F1 score. The best K value obtained was a 23. After training the model, I evaluate its performance using multiple metrics. The model achieved an accuracy of approximately 83.6% along with good precision recall and F1 score. The confusion matrix shows that most predictions are correct with only a few misclassifications. Additionally, the ROC curve shows strong performance with AUC score of around 0.905, indicating good classification ability. The F1 score versus K graph clearly show how the model performance changed for different K values, and it confirmed that K equals 23 gives the best result. Overall, the KNN model performs well for this classification problem.